talk about some shape stuff. So on this section, like most of this is really like you looking stuff up, and then also noticing that none of this is really can be wrong. I just want you to put down some stuff that you should know. And so the first question here: define to the best ability, like without asking the internet, what it means to be a circle. Now this is something that we've been talking about almost on a daily basis. Because there's two ways you can actually define circle. One is using a descriptive definition, and one is using a constructive definition. And so if you say a circle is like a round object and you're still saying that, I'm going to ask you at this point to never say that again because it makes you look silly. Yeah, you're describing a circle well if you're saying it's a round object, but you're not really giving a hint as to why it's actually round. And in the end, that's the way more important thing. Anybody can look at something and describe it like, oh, that over there is a curvy shape, or that over there is a square shape. But fewer people, and this is where it's most important, can actually give you a sense of why it's curved or why it's a square. Or in this case, like why is it actually a circle? Well, if you consider a circle as a shape, I'm just going to roughly draw one here. The curved shape is a result of the property of how the circle is created. And so if you could set this to be the center of the circle and this to be the radius of the circle, you know by now that the radius can actually be taken in any direction. And in fact, there's an infinite number of radiuses that extend from the center of the circle out to the circumference or edge of the circle. And the quality these all have are equidistant. So if you ponder that, I think you'll arrive at a notion that that's actually why it's curved. So if you take like a length of rope and then you spin around your head, it creates a circle not because it's round, but rather because you're never changing the length of rope that you're spinning above your head. In the same sense, none of these radii change, and so where they end up should be in a circle formation around you because all the distances are the same. And so in the end, that's a much better definition. We use a term like locus here. So we say it's like a locus, which just means a collection of points equidistant to a center point. Okay. Now I know, like in the end, like it's more wordy, it's more complicated, but it's also extremely defining. In the sense that if you do this, if you take a collection of points that are all equal distance from a center point, then you will 100% end up with a circle, which is really what this question is kind of getting at. It's not so much like your definition should just describe it because anybody can, but you should think about how. Ooh, that's not a highlighter. You should think about how this makes a circle. In the end, a locus of points that makes a circle is a much better definition to rely on than saying, oh, this thing is generally round. So here I just want you to look up some terms. You may know these already. If not, all you have to do is like literally just ask Google. This is just a fact-finding mission. So isosceles, hopefully you found isosceles to mean something along the lines of two sides of an object that are congruent. Now, if you haven't done this, you should probably also draw a picture. A common example of isosceles would be something like this. You have a triangle, two of the three sides are congruent, it's designated to be isosceles. Another common example is something called an isosceles trapezoid. So these two sides are congruent, therefore we can designate it further as being isosceles. You can think about isosceles as being an adjective that modifies. And so in the same way an adjective modifies a noun in English, isosceles modifies a shape. And so not all shapes are isosceles, but that's a way you could modify that shape. Equiangular and equilateral. So equa is like the key phrase here. Equal means equal. And so here we have angular and here we have lateral, meaning sides or walls. And so equiangular just means all the angles are congruent. And equilateral means sides are congruent. And so an equiangular thing, just again, you should be drawing pictures anyway. A nice example would be something like a rectangle. Rectangles are equiangular because all the angles are 90 degrees. Equiangular and equilateral don't have to be combined in a single shape. Equilateral might be something like a rhombus. All the sides are congruent, and a rhombus ergo is equilateral. Opposite sides and opposite angles, again, these are just kind of like technical terms. This one's probably better fleshed out visually. If we're talking about opposites, we're talking about things across the shape and not touching. And so like these two sides, for example, would be opposite sides. And these guys here would be opposite angles. Now, are those the only examples? No, not at all. So these would also, let's do a different color, hue. These would also be opposite angles. and these guys you can probably guess would be opposite sides. So the term opposite just means not adjacent, in other words, not touching or in a row, separated by some other element. This one is more of a where are you at in this kind of question, so I'm not going to belabor too much. But if all squares are rectangles and all rectangles are squares, that just means I think that you can have more than one designation. And so if I said like if I said something like all Missourians are Americans, but not all Americans are Missourians, like that would be give you a non-math example of how to kind of suss out this relationship. That means there's subgroups basically. If I said all excuse me. If I says again, if I go back to the kind of Missouri example, if I said like all Americans are Missourians, but not all Missourians are Americans, that all of a sudden becomes a very false statement. And so, although this kind of hints that there's some subgroups, it also hints that they're not all the same. It's not true if you rearrange a statement in different ways. In other words, this is a one-way conditional way to look at this. Sorry about that. So that's kind of what the second part is hinting at. If you switch it around, is it always going to be true? Well, certainly with the Missouri, an American example is certainly not true. And you should also think about like with shapes. And so you can replace like these phrases, squares and rectangles, with different types of shapes. But in the end, like it doesn't always make it a true statement. And so if I said something like all isosceles triangles are triangles, but not all triangles are isosceles triangles, that would probably hold true. But if I said like all isosceles triangles are right triangles, but not all right triangles are isosceles triangles, again, now we have a false statement. Since music's playing, I'm going to go ahead and end this right here. I'll see you guys in part 4.